Some functions have graphs that are symmetrical. If a graph is mirrored across the y-axis, we say it has y-axis symmetry, and the function is an even function. We can find out if a function is even by graphing it in the graphing calculator and checking to see if it is symmetrical across the y-axis. For example, we have a function listed on your handout, f of x equals 2x squared plus 1. That roughly looks like this. If you notice, it is mirrored on either side of the y-axis. So we say that it has y-axis symmetry, and we can tell by looking at the graph. We can also check to see if a function is an even function algebraically. If we replace x with negative x and simplify the result, we should get back to the original function. So I'm going to replace x with negative x in this function. Now we can simplify that because negative x squared is positive x squared. So that simplifies to 2x squared plus 1. And this is the same as our original function. So we have an even function. If a graph is mirrored across the origin, we say that it has origin symmetry, and the function is an odd function. The graph of an odd function will look the same when we turn it upside down. The example we have is f of x equals 2x cubed minus x. Let's make a rough sketch of that graph. If we were to turn this graph upside down, which I won't do in the video, you can imagine, though, that it would appear the same as it does right side up. That's a way we can check it out by graphing it. We can also check it out algebraically by replacing x with negative x and simplify the result, and all of the signs should change. So f of negative x I replace all my x's with negative x. Now let's simplify. Negative x cubed, negative times a negative is positive times another negative is negative. So that's going to turn this into a negative 2x cubed. And two negatives here gives me a positive. Now if I compare this with the original function, notice that this term was positive in the original. Now it is negative. This term was negative in the original, and now it is positive. If a graph is mirrored across the y-axis, the x-axis, this is not a function. Remember that the graph of a function cannot be crossed more than once by the same vertical line. In our example, we have y squared plus 1 equals x. The graph of this looks something like that. And notice that this fails the vertical line test. So it is not a function, we call it a relation. But when we draw the graph, we can see that it is indeed mirrored on either side of the x-axis. To test for x-axis symmetry, we replace y with negative y and simplify. Well, negative y squared becomes positive y squared. And we go back, and it does get back to the original relation.